Welcome to our channel. Today we will learn about a scattering of light, which is the B part of chapter spectrum. So scattering of light and its application. We will discuss about these all the things. So let us start. Scattering of light. हमारे दिमाग में ये चीजें जो पहले आती है तो हम लोग कभी कभी सोचते हैं, we think about it कि why sky look blue in color and in evening and morning time while when the sun start to set or just by that time we can see the background of sun is appearing reddish. What is the reason behind these all the things? In daytime, why sky look like cloud look like white? So with these all the questions we have the queries, and for these all the things we have to discuss the reason behind these all the things. So what is the scattering of light? As a definition I will say, by definition, scattering of light, what it is? Scattering is the process of absorption and then re-emission of light energy by the dust particles and air molecules present in the atmosphere. So why scattering takes place? Because in our atmosphere dust particles and water molecules are there, and they have the tendency to absorb and then re-emit, and that phenomenon is called scattering. That is the scattering of light. So one more thing is there. Initially I want to tell you this part we have to remember. In fact, rate of scattering is inversely proportional to wavelength. In previous video also I was asked one question, and that again I will repeat, why red color is used as the danger signal. So reason is that red light have maximum wavelength, एंड जिसका वेवलेंथ ज्यादा होगा उसका डेविएशन कम होता है. ऐसा हमने प्रीवियस वीडियो में देखा था, प्रीवियस लेक्चर में पढ़ा था. जिसका वेवलेंथ ज्यादा होगा उसका डेविएशन, एंगल ऑफ डेविएशन विल बी लेस. सो हियर वी आर ऑब्जर्विंग कि जिसका डेविएशन कम होगा वो उसका स्कैटरिंग कम होगा. जो कम डेविएट होगा वो कम स्कैटर होगा. सो वी कैन से रेड लाइट का वेवलेंथ इज मैक्सिमम, सो उसका डेविएशन कम होगा, सो उसका स्कैटरिंग आल्सो विल बी लेस. सो स्कैटरिंग एंड वेवलेंथ में एक रिलेशन है. दैट रिलेशन वी आर गोइंग टू एस्टैब्लिश, एंड अगेन वी आर टॉकिंग रेड कलर का डेविएशन लीस्ट होता है, और रेड कलर का अगर डेविएशन लीस्ट हुआ तो उसका स्कैटरिंग भी लीस्ट होगा. तो स्कैटरिंग एंड वेवलेंथ बोथ आर इनवर्सली proportional. Wavelength is maximum, scattering will be less. So there is one relation that already I have mentioned over here. Rate of scattering is inversely proportional to wavelength of light or wavelength of a certain color, anything. Okay, so definition already we did. The intensity of scattering of scattered light is found to be inversely proportional to the fourth power of its wavelength. One more relation is given. I is the intensity of scattered light. It is inversely proportional to the fourth power of its wavelength. So जिसका wavelength ज्यादा होगा उसका intensity कम होगा, और जिसका वेवलेंथ कम होगा उसका इंटेंसिटी ज्यादा होगा. That we are talking in terms of intensity. Okay. So further, the wavelength of violet light is the least. Already we have studied wavelength of violet light is 4000 and wavelength of red light is 8000 angstrom. तो जिसका वेवलेंथ ज्यादा होगा उसका इंटेंसिटी कम होगा. तो wavelength of red color is more, so intensity of red color will be least. Wavelength of violet color is least, so intensity will be maximum. Okay, the wavelength of violet light is least and that of the red light is most. Therefore, from the incident white light, violet is scattered most and red light is scattered least. Violet light is scattered nearly 1 by 16 times. Lambda raised to 4 it is. So we can see a wavelength is double. So 2 raised to 4 will be 16. Okay. However, the air molecules of size bigger than wavelength of incident light scatter the light of all wavelength of white light to the same extent. मैं फिर से वो पार्ट पे आ रहा हूं कि why red color is used as the danger signal and what conclusion we have to remember over here. तो red color का wavelength is maximum. So अगर wavelength maximum है तो उसका deviation least हुआ because angle of deviation delta is inversely proportional to wavelength. Already we have studied about it. So by this relation we can say कि angle of deviation is inversely proportional to wavelength. So red light का wavelength is maximum, so उसका deviation सबसे कम होगा और deviation कम होगा तो scattering भी कम होगा. So that scatter नहीं होता, so that will be visible from very long distances. Okay. Next is the fine. Some application of scattering. What are the applications of scattering? Red color of sun at sunrise and sunset. Many example in beginning I was given. And during sunset and sunrise, sun look like red in color. What is the reason? At the time of, again it is the application of scattering. How? We will see. At the time of sunrise and sunset, the light from sun has to travel the longest distance. Why? Because sun is not exactly at what we can say over the head, vertical height. It is at the horizontal level. During sunset and sunrise, sun का पोजीशन क्या होता है अर्थ के कंपैरिजन में? Not at the vertical. It is existing at, it will exist at the horizon. Horizon पे होता है sun. At the sunset and sunrise at both. तो जब vertical height पे होता है तो टाइम पे सबसे कम डिस्टेंस होता है sun and earth के बीच में. And during sunset and sunrise, that distance is maximum between sun and earth. So, since यहाँ पे वही दिया है, since the sunrise and sunset, the light from sun has to travel the longest distance of the atmosphere to reach the observer. Longest distance it travels. Since the blue light of short wavelength, of course blue light का wavelength कम होता है. सबसे ज्यादा wavelength रेड कलर का. ये विबग्योर का स्पेक्ट्रम हमें याद रखना है. यहाँ पे भी VIBGYOR. And one more thing we have to remember, ये स्पेक्ट्रम है. And we have to remember lambda, that is wavelength of red light, is greater than that of the wavelength of violet light. This part also we have to learn. Remember. So blue is in between. Blue कहाँ पे है? ये red है, ये violet है, ब्लू इज इन बिटवीन रेड एंड वॉयलेट, तो ऑफकोर्स रेड कलर से इसका ब्लू का वेवलेंथ विल बी स्मॉलर। तो यहां पे वही दिया द सिंस द ब्लू लाइट ऑफ शॉर्ट वेवलेंथ इज स्कैटर्ड मोर, क्योंकि वेवलेंथ कम होता है, जिसका जितना कम वेवलेंथ है उसका डेविएशन उतना ज्यादा होगा, और डेविएशन ज्यादा होगा तो स्कैटरिंग आल्सो विल बी मोर। While the red light of long wavelength is scattered a little, so it is not much lost. Thus, blue light is almost absent in sunlight reaching the observer, and only the red light reaches us. As a result, the sun and the region near it by it is seen red. I think so. That is clear now. कि जब सन जो है वो कहां पे होता है, हॉरिजन पे होता है एट द टाइम ऑफ सनसेट और सनराइज, बोथ द टाइम इट इज एट द हॉरिजन. बाय दैट टाइम लाइट हैव टू ट्रेवल द लॉन्गेस्ट डिस्टेंस, एंड ड्यूरिंग दैट जो सबसे ज्यादा वेवलेंथ होता है वो रेड कलर का होता है. सो रेड लाइट का डेविएशन लीस्ट होता है एंड ब्लू एंड अदर कलर्स का डेविएशन ज्यादा होता है. तो जिसका डेविएशन ज्यादा हो गया उसका स्कैटरिंग विल बी मोर, सो स्कैटर्ड हो जाता है. सो इट डज नॉट रीच टू द ऑब्जर्वर, बट रेड लाइट हैविंग मैक्सिमम वेवलेंथ, सो उसका डेविएशन लीस्ट होता है, सो स्कैटरिंग लीस्ट होता है, इसलिए वो लाइट दैट रीचेस टू द ऑब्जर्वर. एंड सो द हॉरिजन ऑफ द सन during sunset and sunrise appear as red. Okay. Next application is the white color of sky at noon. In afternoon, sky look like white. In evening and morning, it look like blue. But in afternoon, it look like white. What is the reason? Same reason. We can conclude कि इन आफ्टरनून सन का पोजीशन कहां होता है, ओवर द हेड, एंड लाइट हैव टू ट्रेवल द लीस्ट डिस्टेंस. सो लीस्ट डिस्टेंस ट्रेवल करना है तो स्कैटरिंग कम होता है, ना के बराबर होता है. तो कोई भी कलर का स्कैटरिंग नहीं होता, ऑल कलर रीच एट द टाइम. मतलब सिंपली व्हाइट लाइट कम्स, सो that it look like white. The sun is direct, okay, at noon the sun is directly above our head, so we get the light rays directly from sun after traveling the shortest distance without much scattering of any particular color. Hence the sky is seen white. Next is blue color of sky. Blue color of sky, same reason I mentioned कि अपने एटमॉस्फेयर में जो ड्रॉपलेट्स हैं, एयर मॉलिक्यूल्स हैं या वाटर ड्रॉपलेट्स हैं, उनका वेवलेंथ ज्यादा होता है, तो ब्लू कलर के लाइट को दे स्कैटर एंड रेस्ट ऑफ ऑल डजंट स्कैटर. सो जो स्कैटर होके वापस जाता है, इट लुक लाइक दैट कलर, हमें वही कलर दिखता है. सो स्काई लुक लाइक ब्लू. एग्जैक्ट व्हाट इज हियर, जस्ट वी कैन सी द लाइट रीचिंग आवर आई डायरेक्टली फ्रॉम सन is rich in red color, while the light reaching our eye from all other direction is the scattered blue light. Therefore, sky in direction other than the direction of sun is seen blue. In the direction of sun, it will be look white, but other than the direction of sun, it will look blue. Black color of sky in absence of atmosphere, like on moon, हम वहां पे चले जाए, everything will be look like blue, black, because वहां पे एटमॉस्फेयर ही नहीं है, तो जो सन से सनलाइट आएगा वो स्कैटर नहीं होगा. हमें स्काई का जो कलर है, इट लुक लाइक ब्लू बिकॉज ब्लू लाइट इज स्कैटर्ड, बट जब एटमॉस्फेयर नहीं होगा तो वाटर मॉलिक्यूल्स या वाटर ड्रॉपलेट्स and air molecules will not exist there, so scattering will not takes place in that case. So if there would have been no atmosphere, there would be no scattering of light. No atmosphere, no droplets existing, no droplet will exist, no air molecule will be there, so no scattering will takes place, no scattering of light, and no scattered light would reach our eyes, and thus the sky will appear black instead of blue. Next is why clouds are appear to be white color of clouds. The clouds are near and near surface, near the earth surface is not too far away, and they contain dust particle. Cloud contain dust particle and water droplets also, and aggregates of water molecules of size bigger than that of the wavelength of visible light. जो water molecule के particles हैं उनका size is bigger than that of the wavelength of light incident. Therefore, the dust particles and the tiny ice particle present in the clouds scatter all colors of incident light from sun to the same extent, and hence when the scattered light reaches our eyes, the clouds are seen white. Last is the use of red light for danger signal. Number of times, I think so 2 times I have already mentioned this part, but again we will see. So in the visible light, wavelength of red light is longest, maximum. Therefore the light of red color is scattered least. तो जिसका वेवलेंथ ज्यादा है उसका स्कैटरिंग लीस्ट होगा. मैं फिर से यहाँ पे रीजन लिख देता हूं कि सिंस डेल्टा एंगल ऑफ डेविएशन इज इनवर्सली प्रोपोर्शनल टू वेवलेंथ and rate of scattering is also inversely proportional to wavelength. In beginning I was mentioned that rate of scattering is inversely proportional to wavelength. जिसका वेवलेंथ सबसे कम होगा उसका स्कैटरिंग सबसे ज्यादा होगा, जिसका वेवलेंथ सबसे कम होगा उसका जिसका वेवलेंथ सबसे ज्यादा होगा उसका स्कैटरिंग सबसे कम होगा. तो रेड लाइट का वेवलेंथ इज मैक्सिमम, सो इसका स्कैटरिंग सबसे कम होगा. सो हमें दूर से वो लाइट दिखेगी बिकॉज उसका इंटेंसिटी विल नॉट लॉस्ट. Okay, so therefore the light of red color is scattered least by the air molecules of the atmosphere. Hence the light of red color as compared to light of other colors can penetrate to a longer distance without becoming weak. Thus red light can be seen from the farthest distance. So red light is used as the danger signal. So we complete C part of the spectrum, which is the scattering of light and its application. I will request to everyone, please like, share and subscribe my channel. Thanks for watching this video. Thank you.